Hi, this is Mr. Max. Today I am doing graphs of exponential functions, graphs that are typically in the form y is equal to a raised to the power of x. So what you need to understand, what makes this different from, say for example, quadratic functions is that here the base is known to us, but the exponent is the one that is not known to us, okay? But the base that we are going to work with will be a rational number, okay? A positive integer, rather. So we're going to work with positive integers, positive whole numbers, okay? And obviously we're not going to work with 1, okay? Because if it's 1, it just flat lines, becomes just a horizontal line, all right? So the index is the one that is unknown. Right, so the two major ones I'm going to have a look at is y equals to 2 to the power x, and I have here a graph of it so that you can see. Now you would see that even if I bring y equals to 3 to the power x, that these graphs are passing at 1, because if you input x equals 0 here, you're going to get y as an output. All right, so y equals to a to the x. If you have 0 for x, it's going to pass at 1. And again, the graph is not going to cut the y-axis because you can't have 0 here. Y cannot equal to 0. So this is the type of graphs we're going to have a look at. So what I'm going to do, I'm going to do two questions of y to the power 2x, and then I'm going to add another function in there, and then also y equals to the power 3x, and also a function in there. And the best way for you to be able to do these particular graphs is for you to have a table of values and to follow, all right, that construct a table method, and you plot the points, and then you join them with freehand, and then you answer subsequent questions. Right, so the first question I'm going to have is the function y is equal to 3 to the power x. So what you have here, you're supposed to find the value of p and q. So this is basically if you find p when x is negative 1, all right, you're going to get 0.33 recurring. But I'm just writing it to two decimal places because on a graph it's going to be difficult. So we'll probably work with one decimal place when we plot. And when obviously q, when x is 0, you're going to have 1. So that completes that particular table. All right, but then there's another one here. It's a quadratic function, as you can see, 3 minus x squared. Now, what you should also remember from quadratic function, if this graph has to be drawn, it will typically be something like that. And this one here, it will typically be something like that, okay? So this is the graph that I am expecting us to work with, all right? But we're going to do them on the same grid, so to speak, all right? So R here, you just simply find R by subbing in that 0 for x into your function, and R is equal to 3. Always make sure that your table is correct, and you are supposed to have a parabola which is like this, and also an exponential function that goes in that direction. Right, now they're giving me a scale. So they're saying if I bring my tables back here, all right, the completed tables, they're saying on a sheet of graph paper, you're supposed to use a scale of 2 centimeters to represent 0.5 units on the x-axis, and also 2 centimeters to represent 1 unit on the y-axis. It's very important that you get this, okay? So basically, I look at my table, and obviously I know my x value should be, this particular one, between negative 1.5 and 1.5. All right, so I'm going to work with negative 1.5 to 1.5 on my x-axis. My y-axis, you have to find the highest value. Looking between the two tables, you realize that 5.20 is the highest value. So it will be good if I can go all the way up to 6 when I do my table. And what is the lowest value of x? Well, the lowest one here is negative 0.25. Right, so essentially this is what I'm expecting to get. So I quickly just sketch the thing so that you can have an idea. This is the region that I'm going to use, and you make sure that you follow the particular scales that are given. Right, so I'm still doing the question that says I must now draw the graphs. Okay, so I have got my graph paper here and also the correct scales as required. So let me bring in let me bring y equals to 3 raised to the power of x. So these are the completed tables, the values. Now I'm going to plot these values here, and I expect the graph to pass at 1 here, because you can see the point 0, 1 is here. That is when x is equal to 0. So if I plot negative 1.5 with 0.82, so you're going to find somewhere there. So if I plot negative 1, 0, 0.33, it's about somewhere here, all right? And then if you plot negative 0.5 and 0.6, that's about somewhere red, we can see that. And the point 0, 1 is on the y-axis, the point 0.5, 1.7, the point 1.3, and the point 1.5, 5.2. So these are the points, and you then draw this graph of your freehand and you label it. So that does it then for the exponential graph. Right, so let me bring in then the table for the quadratic function. Remember I said how this table is supposed to look like. So again, I'm going to start off with my points. Negative 1.5, 2.25. So negative 1.5, 2.25 is somewhere there. So the point negative 1.3 expected to be all the way up here. The point negative 0.5, 3.25. And the point 0.3 has to be on the y-axis, as you can see. And now I'm looking for the point 0.5, 2.25, or 2.3. Then I'm expecting the point 1.1 to be all the way here. And lastly, 1.5, negative 0.8 is all the way down here. Right, so when you have plotted, then you must plot all the points because you are getting marks for plotting all the points. And then you join your points with a curve, a smooth curve that you draw with your free hand. Okay, do not use a ruler, and I have then labeled my x's, my function, as you can see there. So this is the way you answer part 2, where they say you're supposed to draw them on the same grid. So let me bring my graphs back here, because now here I have got 3 sub questions that I have to answer. So the first one here says we are supposed to find, but you use your graph, and this is very important, people. Do not use algebra, you use your graph. So when you are finding the function 3 minus x squared equals to 0, that is this particular red one here, okay, because I've labeled it. So we're going to find where does this graph cut the y-axis, the x-axis, because the y equals 0. Okay, so everything here, when you have equals to 0, that is meaning that you are supposed to look at the line y equals to 0. And here, I'll look at the line y equals to 4. All right, and here, I just have to look at where these two functions are equal to one another. So that is very important that you get that out of the way, that you do not make the mistake. So the first part, we want to find where the red one cut the y-axis. As you can see, the x-axis, you can see it's halfway here. All right, now we can estimate that particular value. Now here's the thing, now you also need to make sure of your scale. Okay, so you must make sure that you understand your scale. Right, so for example, this here is halfway between 1 and 1.5. So 0.5, okay, when you divide 0.5 by 10, because you have got 10 small squares in there. All right, so let me then take what I mean by that. So if I take 0.5, okay, and I divide that by 10, and I want to find how much does one little small square represent. So one small block, all right, one small block like this one here, it's representing 0.05. So 2 of these blocks, okay, so 2 of these blocks I expect to be equal to 1. Okay, 0.1, sorry, because you take 0.5, 0.05 plus 0.05. So one of them or 2 of them will be 0.1. So this is, for example, 0.1, 0.2, 0.3, 0.4, 0.5. Okay, so let us find out what this particular one is here. So that's 1.1, 1.2, and about 1.3. Can you see that what I have done there? So you must make sure that you get to understand the scale, so you do not make a mistake whenever you are finding that particular estimation. You must find out what does one little small square represent. So the next question is, we are supposed to find the function 3 raised to the power of x equals to 4. So we want to find the line. So I'm going to bring in the line here of y equals to 4. And I will find where does this line cut our black one here, the y equals to 3 to the power x, the exponential function. And where it cuts, where they intersect, I read of the x value. So that is going to give me more or less an estimation. So again, it's about 1.25. Make sure that you understand the reading from the scale as I've indicated before. Okay, so if that one is a little bit out again, so remember we said 2 blocks here, all right, 2 small blocks, they represent 0.1. So you have what, 1, then this is 1.1, this is 1.2, all right, so it's halfway between 1.3 and 1.2. So that's so you'll see I'm getting about 1.25, all right, so very close to the other one there. So anyway, you will have an answer, because we are giving these answers close to what we call, an estimation. So normally we give you a range like between 1 decimal place and so on. Right, so the third one here is basically you are supposed to find where does the exponential function intersect with the quadratic function, which means it's this little point that we are looking for where they intersect, and then we read off that particular x value, and that is about 0.6, and that is how you form or solve this equation. You do not solve them graphically, by means of using algebra, but you solve them by means of using your graph, the information in your graph. The more points you have, the smoother your curve, the more accurate your answers become. Okay. Right, so let me bring in question 2. It's a very similar question. So you have got the function y equals to 2 raised to the power of x. Again, this is an exponential function. And you have got some missing values of a that you are supposed to find. So once x is negative 2, yeah, you get 0.25. Once x is 3 here, 2 raised to the power of 3 gives you 8. Once x is 4, then you get 16. Okay, so that completes that missing information for that table there. So we'll bring in another function here. Now, one of the things that with this function at first, because it's not multiplied out, right, it's still in its factored form. So when you multiply out, you will realize that you're going to get negative x squared plus 4x. So what this particular function tells me here, it's going to be parabola that goes this way. Okay, and another thing that it tells me also is that this particular parabola has no value of c. It has no y-intercept. All right, so it's going to pass the x-axis at 0. So I'm going to expect it to pass at 0 here. All right, and then the other particular point here is going to be perhaps 4. All right, the way I know it will be 4, well, if you take this particular equation, all right, so if you take this particular equation, this one has to be a minus now. All right, if you take this particular, it's a positive, it's correct. If you take this particular equation and you factorize it, or you say 4x, okay, that is x times 4 minus x squared, and if it equals to 0, okay, and you solve it, remember the way you solve it is you take out a common factor. If I take out a common factor, I get 4 here minus x, all right, equals to 0. Then the answer x equals to 0 is already there, but everything outside, 4 minus x equals to 0. Then negative x equals to negative 4. Then obviously x equals to 4. So I know it will cut the x-axis at that particular point as well. That is if I use algebra to solve that particular question. Right, but we are supposed then to, we are given a table of values. So we will find that particular value, x equals to 4, where it cuts the y-axis from our table. Okay, so there is no need for you to apply this. It's just that it helps me so I can know how my function will look like before I just blindly start sketching things. Or to sketch things, you need to have an idea, a sketch in your head. All right, so we have the table here, and we have got some missing values of d and e. So d, when x is negative 1. Now realize something, I put it in brackets. I suggest you do the same so you do not make a mistake. Okay, then you get d to be negative 5. And then if e is x is 2, then the value of e becomes 4 then. So the table will be complete. So I expect part C of the question to want me to draw it, and they will give me particular scale, all right? But you will see that the graph I've used my own, all right? But I expect you to follow the scale that they are giving you when you have your graph paper. Right, so part C again, you have got all the information here. They are saying use a scale, all right? 2 centimeters represents 1 unit on the x-axis, 1 centimeter represents 2 units on the y-axis. Then you draw the graphs. So if you have graph paper, you must follow then this particular instruction. Okay, so if I bring back my table, my complete one for the exponential function is here. And the reason why I'm bringing my tables back here is because I want to find out what is the highest y value. Okay, how high up should I go when I plot them? So highest y value is 16. And what is the lowest y value? Of course, you can see it's -5. Right, so they're giving me my x from -2 to 4, -1 to 4. So I'll use -2 because -1 is included here. So I know that my graph then is going to be from -2 to 4 for the x-axis, okay, the x scale. So I expect something more or less like this. This is a region I will be working. I have my sketch there. The one in blue indicates my exponential function, and the one in red indicates my quadratic function. It becomes quadratic when you multiply this one out. Okay? So you take your graph paper and you follow that, and then you find these particular points. So you can't really plot the point 0.25, but I suggest you plot the point 0.3 to 1 decimal place. Right, so I have my particular graphs here. So this one here in red or pink is the function y equals 2 to the power x, that is the exponential function. The one here in black is the function y equals to x, in bracket 4 minus x, so this is the quadratic graph, okay? So you would have only have drawn it until here at 4, where it would be ending. Right, so now they are giving me 2 questions here for me to solve. So they are saying you are supposed to use your graphs to solve the following equation. So that is the exponential equation. 2 to the power x equals to 10. Please, you do not use logarithms here to solve. This is not what we are doing. So we are going to find a line y equals to 10. All right, so when you find that line y equals to 10, you then have to look, where does that line cut our particular function? And you can see I've indicated it here. Now let me just talk briefly about my particular graph and my scale, so that you can have an idea what is it that I have done here. So I realize that between 1, all right, if I divide 1 by 5, because you have got 1, 2, 3, 4, 5 little blocks here, all right, and each little block represents nothing but 0.2. So when I'm here, this is 3.2 and 3.4 will be here, so halfway between that. So I'll accept an answer of about 3.3 for that particular solution, all right, to this particular graph. So it's very important that you do understand how is it that you find this value. All right, so I'm going to repeat. If you look, I take 1 divided by 5, all right, because it's 1 unit, all right, 1 unit divided by 5 blocks. All right, so if you divide 1 unit by 5 blocks, and that gives you 0.2, all right, that is what one little block represent. So this is 0.2, 0.4, 0.6, 0.8, then you have 1, 1.2, 1.4, 1.6, 1.8, then you have 2. All right, so if I have 3.2, 3.4, so in between here is where I find this particular value. I hope that that makes a little bit of sense, that you have seen it. So you must be able to find out what does your square, or what does one little block or one little square there represent on your particular graph. Right, so the second part here is basically a straightforward. Again, it's similar like the one before. We are supposed to find what is the value of x where these two functions are exactly equal to one another. So it means then in graph language, if I take my function here, the exponential function, and I take my function here, the quadratic function. I want to find where they are equal, and the point where they are equal is the point where they intersect, and I give my x values. This one is straightforward. You can see that it is x equals to 2, and since it's a whole number 2, if you punch in here 2 raised to the power 2 is 4, you punch 2 and 2 here, you're going to get the same answer. Okay, but it's going to be an estimation for the second part though, because they are cutting here and it's not a whole point, right? So when you have it here, remember again, what does one little small square represent? So that's by 0.2, 0.4. So I expect it halfway between 0.2 and 0.4. So something in the region of 0.3, and that is where I expect that particular solution to lie.